This battery is a source of DC, or direct current. The speaker isn't really designed for a direct current signal like this, so I don't want to keep the battery connected for too long, as it will eventually result in excessive heat across the coil. The speaker is designed to play audio, which is alternating current, or AC. Alternating current is a series of positive and negative voltages, and we can visualize this by quickly alternating the polarity of the battery. The series of positive and negative voltages across the coil causes the speaker cone to move outward and inward, which results in a series of positive and negative pressure changes in the surrounding area, also known as sound waves. This battery demonstration helps to get a basic understanding of how a speaker works, but let's look at this transducer for a more realistic example. This transducer operates on the same principle as the speaker. There's a positive and negative terminal, which are attached to a coil of wire within a magnetic field. Rather than nearly instantaneous positive and negative voltages from a battery, this amplifier is supplying a sine wave at the specified frequency. And you'll notice that the transducer is moving outward and inward more smoothly. As I increase the frequency of the sine wave generated by the amplifier, naturally the outward and inward cycles happen more frequently. What do you think will happen if I reverse the polarity? Now, negative voltages from the amplifier might result in outward excursion of the speaker, but is there really a difference? The result is essentially the same. The transducer moves outward and inward at the specified frequency. Visually, there's no difference, but can we hear a difference? First, let's adjust this sine wave up to a frequency that we can hear. Then we'll compare that to the sound when we invert the polarity by switching the wires from the amplifier. There's no audible difference. We hear a 300 Hz sine tone in both cases. Over here in the DAW, we have a 300 Hz sine tone that begins with a positive.
Request accepted.
Inverting the polarity means the sine wave will now begin with a negative, because all positives become negative and all negatives become positive when you invert polarity. There's still no audible difference because the two signals are really identical after the initial positive or negative start. Do you think the difference would be more audible if we used a more musical signal, like a snare drum? Right here I've loaded a snare drum sample into the timeline, and if we zoom closer, we can see that the waveform starts out with a very quick positive transient. Surely we'll hear a difference now with such a transient signal, right?
Request accepted.
There's still no difference to my ear. I've heard some claim they can hear a difference here, and that might be true, but I don't hear a difference at all. If you can hear a difference, let us know in the comments below. So does all of this mean that there's no audible difference when speakers are wired backwards? Well, yes and no. If you just have one speaker, you probably won't hear a difference, even if you reverse the positive and negative on your speaker cables. But when you add in additional speakers, it becomes much more important to get the wiring right, because now the two speakers will either work together or work against each other. I've duplicated the 300 Hz tone to another track. These two signals are now exactly the same. I'll begin with one muted, and we'll see that the signal level from the one that is unmuted comes in at about minus 18 dB full scale. What do you think will happen to the meter when I unmute the second copy? The two copies sum together, and the meter increases by 6 dB. Okay, now let's invert the polarity of one copy so that the positive sections become negative and the negative sections become positive. What will happen to the meter now when the two copies are summed together? We see just as much level on each copy, but because they are total opposites, they now cancel each other out when mixed together. And this results in no signal level at all. The same thing can happen if you have two speakers in the room wired with inverse polarity. The speakers will each sound identical on their own, but when you play them both together, they'll work against each other and cause cancellations. Generally speaking, you should wire the positive terminal on the amplifier to the positive terminal on the speaker, and the negative terminal on the amplifier to the negative terminal on the speaker. Though you won't hear a big difference if all the speakers are wired the same way, you will hear a big difference if the speakers in the system are wired differently. So be sure that all of the speakers are wired the same way so they can all work together. While this is a good starting place, getting the speakers to work together is a bit more complicated in the physical world, because space, time, acoustic reflections, and phase will be added into the equation. That's what we'll be talking about in this video that's on your screen now. Go ahead and click that link, and I'll see you there.